Good evening everybody who is watching this video, this is my review video of the second week. And today's topic will be about the MOSFET. So for the M means metal, the O means oxide, and for S means silicons for the right side. So for the cap, the capacitor. So seeing the structures of the MOSFET for the left side, we call this sector as gate. The gate may be produced as metal or super heavily doped by N-type silicons. So you can see that the panel level energy is almost nearly or same as the conduction band of energy band in N-type. And from the center, we call this as the dioxide silicons. In the middle sector, its resistance is very high, so the current can flow these middle sectors. And further to the right side, we call this the P-type of silicons. So we can see the features. The features, in the third place, Hall carrier will higher than electrons carriers. So we can draw the panel level energy like this, more closer to balance band. For the center of the dioxide silicons, it seems it's resistor, or I think. So the panel level energy will be in the center, same distance from the conduction energy end, and same distance from the balance energy band. So we integrate these three materials or junction these materials into one. So we call this as MOSFET. So there, for my opinion, there's two types. For first, non-flat band. In this situation, we call it as thermally equilibrium. So in this situation, we see that the panel level of energy in the is flat. And here, can you come closer? So you see here, there is some banded energy band layer. Since this happens by the potential energy difference between the middle layer and the substrate or body sectors. And we want to get this energy band more flatted. Then we get some voltage induced, so we can make like this flat band energy. So we need the voltage flat band to make this flat energy band diagram. So we call this the equation will be about, guess there is a vacuum energy band layer, and by each panel level difference between the N-type and P-type, difference of the panel level of N gate and the substrate difference, and we induce voltage, and it will make some flatted energy band diagram. So this is how we flat band make M1 partition. As I said, both capacitor. Let's see here. In here, you can see that the balance band is getting more far from the energy of the panel layer, so we can see this. At here, the mobile carrier's concentration is getting down and down. So we can see this sector as depletion layer. Depletion region. No current flow. Only ionized atoms, donor or ethant ion, stay here. So likely the p-n junction, we can draw like this. P-type silicons and the minus ionized, and here for plus ionized and N-type silicons. So we know there is some voltage barrier. So if the electron want to pass this, then it have enough energy to pass to overcome this voltage barrier. So look here, plus and minus. So here it induces the strong electric field. Electric field is produced. So by this property, we can say that Morse cap is one of the capacitor's function. Okay, this is the end of the review. Thanks for listening. Goodbye.